This video is quadratic applications about maximizing area. This time we have Farmer Brown built a rectangular pen for his chickens using 12 meters of fence. He used part of one side of his barn as one length of the rectangular pen, and he maximized the area using the 12 meters of fence. Then we have Farmer Johnson built a rectangular pen for her chickens using 16 meters of fence. She also used one part of the side of her barn as one length of the rectangular pen, but the length of her pen was 2 meters more than Farmer Brown's, and the width of her pen was 1 meter more than the width of Farmer Brown's. The question is, how much larger is Farmer Johnson's rectangular pen than Farmer Brown's? So we want to figure out the area of Farmer Brown's and then Farmer Johnson's, and then figure out how much bigger Farmer Johnson's is than Farmer Brown's. So let's figure out Farmer Brown first to figure out what his maximum area is. So this is Farmer Brown's. His rectangular pen, this is Brown. He used only 3 sides of his fence because one side is his barn. So this is fencing, fencing, and fencing. And he used 12 meters of fence. So we know that's his perimeter. So we have 12 meters is equal to 2 lengths plus 1 W. Because we'll have a length, and a width. You could also do W plus length, but it's the same. It'll end up being the same information. So now to maximize his area, we know his area is length times width. So let's solve for this width. Width is equal to 12 minus 2 lengths. So we know his area is equal to his length times the width of 12 minus 2 length. So let's put this in standard form. So area is equal to negative 2L squared plus 12L. So we have it in standard form. Let's find his maximum area to find his vertex. So for Farmer Brown, his axis symmetry is negative B, so negative 12 over 2 times negative 2. So that's negative 12 over negative 4, which equals to a positive 3. So his maximum area is equal to negative 2 times positive 3 squared plus 12 times positive 3. So we have, I'm just going to use my calculator real quick, so negative 2 times 3 squared plus 12 times 3 is equal to 18. So his is 18 feet squared. His max area is 18 feet squared. So Farmer Brown max area equals 18 feet squared. So now let's do Farmer Johnson's. Farmer Johnson did the same thing, where she only used 3 sides for fencing and 1 side of her barn. But this time she used 16 meters of fence. Sorry, this should have been meters squared. I will fix that. This should be meters squared, because he did meters. Same thing with Farmer Johnson. She used 16 meters. So her perimeter will be 16 equals 2L plus W. So then her width will be 16 minus 2L. So her area will be 1L times 16 minus 2L. So in standard form, same thing that we did for Farmer Brown. We're going to have our area is equal to negative 2L squared plus 16L. So let's find her axis of symmetry, or basically her length. So AOS will be x equals negative times 16 over 2 times negative 2. So that's negative 16 over negative 4, which is positive 4. So let's just make sure. So her length, that was her L. Both of these are lengths. So Farmer Brown's length was 3, and Farmer Johnson's length was 4. Which in this case, it would actually be her width instead. So, because it said the width of her pin was 1 meter more than the width of Farmer Brown's. So, this would actually technically be her width, but because we're dealing with dimensions, it'll be okay. So then, if we finish this and we found the other dimension, it would be 2 meters more than Farmer Brown's, and we can actually check that as well. So let's go ahead and find the area of this. So the area will be equal to -2 parentheses 4 squared plus 16 times 4. So let's check. So we have, this time it's -2 times 4 squared plus 16 times 4, which is equal to 32. So Farmer Johnson's max area was equal to 32 meters squared. Now, just to make sure we did this right, so again, we had this AOS was 3, this one was 4, so it's 1 meter more. So if Farmer Brown, if we go back to the area, we know 18 was max area for that. So 18, and it's length times width, so if we divide that by 3, we know the other dimension is going to be 6. So we know that for Farmer Brown, his dimensions are 3 by 6 are his dimensions. Then for Farmer Johnson, we have the area is supposed to be 32 meters squared. 32 divided by the length that she had was 4, so her dimensions are going to be 4 by 8. So 4 by 8. So if we re-examine this, we're supposed to have 2 meters more. So 6 and 8. Hers is 8, his is 6, so 2 meters more. And then 1 meter more, which is 4 and 3, so that is 1 meter more. So we did that correctly. So the maximum area that she has is 32 meters squared, and the maximum area he has is 18 meters squared. So Farmer Johnson's rectangular pin is 32 minus 18 is 14. So Farmer Johnson pin is 14 meters squared bigger than Farmer Brown. So all we did was just subtract the 2 maximum areas that we found. So again, I just checked to make sure that one of either the length or the width, this one says the length is 2 meters more, but I ended up using that as the width, and the width was 1 meter more. I ended up using that as the length. So it's still the same dimensions. So 4 is bigger than 3 by 1, and 8 is bigger than 6 by 2. So we have the correct ones that are bigger. So our answer is still correct in saying that it's still bigger by 14 meters squared.